Assalamualaikum and good day to my panel, Dr. Ng and Encik Sofian. My name is Afika Izzati binti Azmishan. Today we'll present to you about the development of portable data logger and IoT device for pressure meter as my final project. The problem is because the landslide frequently occur. It is due to the lack of monitoring system. The engineer need to check the slope manually while the soil has low stability due to high water content and give high pressure in soil. In addition, deforestation that caused from the human factor. Therefore, we need to develop portable data logger and IoT device for pressure meter to detect pressure parameter in soil. Okay, this slide will present to you about the objective of this project. Okay, first is to identify the Internet of Things IoT devices in detecting pressure parameter for slope monitoring. Second, to install and test the variable of IoT slope device in civil engineering field. And then lastly, to analyze the data from IoT slope monitoring device and correlate with slope stability. Okay, to achieve those three objectives, so the method is firstly we identify the IoT device and then we install the device. And then lastly, we analyze data from IoT device and correlate it with the slope stability. Okay, this is to identification of IoT device method. We need to identify for the portable data logger from the previous research. So we have Arduino Uno, portable wireless body sensor data logger, and the data recorder DS1307 Arduino Uno SD card. Next, we will identify the pressure sensor from the previous research. So we have fiber Brett Gratty FBG soil pressure sensor, CPS120, and the BMP180. Okay, the next step will be the installation of IoT device. Okay, we have two components in this step, which is the hardware component and the software component. For the hardware component, we have BMP180, Node MCU, data logger, breadboard, USB cable, male to female jumper, and male to male jumper. Okay, will be the software component. Okay, after we set in this software component, we have two software, which is Arduino software and the Blink application. Okay, after we set up all the hardware component that come from the previous slide, okay, we will set up the coding for sensor and Blink in this Arduino software, and then verify the code to detect if is there any error occurred, and then after verify, we uploaded the coding to the sensor, and then both sensor and Blink connected to Wi-Fi, and the data appeared either in serial monitor in the Blink and in the Arduino software or Blink application itself, and the data was recorded. Okay, this is the step for analyze data from IoT device. Okay, first we place 3 kg wet granitic residual soil from site in the container, and then waited and record the reading and dried for 24 hours, and then waited again for dry condition, and then we mix dry soil with 300 grams of water as 10% moisture content, and then fill the soil into a cylinder container. The pressure sensor was inserted into a depth of 0.1 meter, and the resistance value was recorded. The step 7 was this step was repeated for 0.2 meter until 0.5 meter. Okay, all the steps from 1 until 8 was repeated for 50% moisture content and 100% of moisture content. Okay, next slide will present to you on the result and discussion. To achieve objective 1, the BMP180 was chosen as pressure sensor for detecting pressure parameter in soil. Meanwhile, data logger DS1307 was selected to be used to store data that delivered from the sensor. To discuss from the previous slide, fiber Brett Gratty FBG was used for research purpose and had been tested at Taiyuan railway station. This sensor was expensive and the performance was verified experimentally. CPS120 was expensive and hard to get due to high demand and limited. That's why BMP180 had been chosen, since it is easier to get and affordable. BMP180 had several features such as low power consumption, including temperature output, high precision with low power consumption mode. The data logger DS1307 also affordable and easy to get. It was also had some features that more update rather than data logger before this. This data logger can store data using SD card either 16 GB or 32 GB, and it is also used lithium battery CR1220. Okay, to achieve second objective, we need to, this figure shows on the hardware component was setting up before use. Okay, the USB cable was connected to the laptop and to the Node MCU. Okay, this BMP180 and data logger is connected to the Node MCU via female to male jumper. All of the hardware component was attached to this breadboard. Okay, this is for the software component. The coding had been setting up in this Arduino software. The coding related were BMP180, ASP8266, which covered the Node MCU, DS1307 for the data logger, and the Blink for the Blink application. So the coding was verified and then uploaded to the hardware component. The value of pressure can be seen as either at serial monitor, this one is the serial monitor from the Arduino software, or a Blink application in the next slide. Okay, this figure shows on Blink application. Okay, this is the gauge which shows the reading pressure in soil for 10% of moisture content. Okay, this application is free and easy to get by downloading it through the Google Play Store and iOS. Okay, the Blink used to display the value from sensor and can be read from anywhere. The Blink can be used to monitor the slope, thus reduce slope failure. It is also can notify the user if something major occurred. Therefore, the authority can be aware and find solutions to the problems that occurred, thus reduce number of accidents and deaths. Okay, the figure shows on the result occurred from the sensor of BMP180. The pressure increased as the depth of soil increased. In 10% of moisture content, the slope tends to be stable due to less water content. At this range, the engineer or responsible authority no need to be worried since it did not show any danger. Okay, this figure shows the value of pressure at 50% of moisture content. As the depth increased, the pressure also increased. So the pressure at range 4 cm until 8 cm tend to have sudden increase due to high pressure that occur in soil. At this state of 50% of moisture content, the slope becomes at medium risk at the water content moderate. Therefore, the responsible engineer or authority need to be aware as soon as they get the notification through Blink on this mode of slope. Unfortunately, when the sensor was to be tested for 100% of moisture content, there is no measurement verified and it seems like the slope failure had occurred. Okay, based on the previous researcher from Kaohsiung Ren, fiber break grating sensor had 6 surface. This gave result on 6 reading of pressure from different directions. The observation done within 3 months which from 11 August 2018 until 10 October 2018. This figure shows on the result from the FBT sensor. The trend of monitoring value in section 2 is similar to the section 1. At the initial stage of foundation pit excavation, the soil pressure changes rapidly. The soil pressure change speed tends to be stable in the latter stage of construction. The maximum monitoring value of section 1 and 2 are lower than the maximum soil pressure allowed by the diaphragm wall, which certifies the safe, stable, and orderly construction condition on site. So based on the FBT sensor research, different stages for the excavation of the foundation pit obviously affect the change of soil pressure, and the soil pressure of the pre-buried sensor increases gradually. Meanwhile, by using BMP180, this sensor had been tested at different moisture content in order to analyze the soil pressure parameter for monitoring soil from fail. Lastly, I will tell you on the conclusion. In conclusion, the BMP180 and data WPS1307 can be applied in detecting pressure parameter in slope and correlate with slope stability. Although the BMP180 cannot be measured at 100% moisture content, then it will have an invention to it so that it can be more useful in future. The BIM application is a good platform as IoT device for iOS and Android application in order to control the Arduino and the lights over the internet. This BIM application is not tied with specific board, and you can build graphic interface for your project by using the widget that applicable in this application. Blink is a good medium to monitor and identify scenes once you get online and ready for Internet of Things. Thank you for listening my presentation, and we'll continue to the Q&A session.